Hello, and welcome to Roly Poly Weight Loss. I'm your host, Roly Poly. Welcome to day 34. Okay, let's get started. Okay, so today I am going to talk about something that I discovered while I was researching environmental factors for obesity. And these are what I'm going to call wildcard factors, though many of them are tied to environmental factors. So I'm not going to add wildcards to the list because they're not as well studied as the things here, but there's something I found really interesting that I just wanted to share. So, science writer David Barabee wrote an article for the newsletter Aeon laying this out, and it really is fascinating. I really suggest you read it. Now, we know that certain factors, like the ones from our list, have been linked to obesity. But we also know that scientists aren't 100% sure what all can cause obesity. Just as how some medications can cause obesity, scientists and doctors don't know why. If we knew everything that caused obesity, or the one thing that caused obesity, we would just change that one thing and be done with it. But what's far more likely is that there are many reasons, possibly working together. So as we touched on with genetics and environment, they work together. It's very possible that there are a dozen different things causing your obesity. And the more of them you know that might be causing it, the more you can look into it and mitigate that, the better likelihood you have of actually losing the weight. So, this is where the Aeon article comes in with some mind-blowing wildcard factors. So first, the discovery that proves that some wildcard factors must exist. What makes us think they are there is that it isn't just humans becoming bigger. This is the mind-blowing part. Over the past 20 years or more, as the American people were getting fatter, so were America's marmosets, as were laboratory macaques, chimpanzees, velvet monkeys, and mice, as well as domestic dogs, domestic cats, and domestic and feral rats from both rural and urban areas. In fact, the researchers examined records on those 8 species and found that average weight for every one had increased. So for lab animals, we're talking 9% to 35% increases per decade. So those lab monkeys are becoming almost as fat as people relative to their size. I mean, 35% increase per decade, and they said this is over the last 20 years. So that means that is a 70% increase in 20 years. That's well over half. That's just shy of 3/4 of their weight over again. And again, it's multiple animals, multiple species, not just all of them are primates. There's mice, cats, dogs. There are lab animals, there are pets, there are feral animals. It's across a huge spectrum. So they note, it isn't hard to imagine that people who are eating more themselves are giving more to their spoiled pets, or leaving sweeter, fatter garbage for street cats and rodents. But such results don't explain why the weight gain is also occurring in species that human beings don't pamper, such as animals in labs, whose diets are strictly controlled. In fact, lab animals' lives are so precisely watched and measured that the researchers can rule out accidental human influence. Records show those creatures gained weight over decades without any significant change in their diet or activities. So, while it's easy to make excuses, about our trash or our habits for our pets, these lab animals, by all logic, if it was purely a genetic um, or environmental in terms of how much you eat factor, these lab animals would not have gained the weight, and not consistently across like whole species. So because we have such stringent controls and data tracking, we can show definitively that these lab animals have gained this weight. And it can't be a matter of their willpower not to eat more food, or their TV watching lifestyle, or the fact that they sit at a desk all day instead of doing something active like, I don't know, mountain climbing. It can't be that for lab animals. So that means there must be a factor affecting these animals that, surprise, surprise, could also be affecting us. Obviously, if animals are getting heavier along with us, it can't just be that they're eating more Snickers bars and driving to work most days. On the contrary, the trend suggests some widely shared cause beyond the control of individuals, which is contributing to obesity across many species. So, this is where those crazy wild cards come into things. What kind of factors could be affecting people, lab animals, and possibly also pets and feral animals? So this is where we get to things that have less research done about them, but that we know something must be there. So, Barabee compares these wildcards to the typical, or as he calls it, thermodynamic model of weight gain. Basically, it's the thing we all get told. If you put in more fuel, food, than you use or burn, then that fuel has to go somewhere and it's stored as fat. If you use more than you eat, then you'd burn your stores and you'd lose fat. This is, as we've seen before, this is the "it's simple science" fallacy that people who are roly-poly get told all the time. If you just worked out more than you ate, you'd be fine. It's simple math, or it's simple science, or as he says, it's simple thermodynamics. And if it was that easy, no one would be fat. But, as Barabee points out, that doesn't apply to lab animals, or feral rats who spend all day foraging for food. They're not exactly pampered. And people who were fat because of their own lack of willpower, that wouldn't follow clear patterns. That would just be a person with no willpower would be fat. People around them wouldn't be because they had willpower. But that's not how it works. There must be other wildcard factors because obesity follows patterns. Many other aspects of the worldwide weight gain are also difficult to square with the "it's just thermodynamics" model. In rich nations, obesity is more prevalent in people with less money, education, and status. Even in some poor countries, according to a survey published last year in the International Journal of Obesity, increases in weight over time have been concentrated among the least well-off, and the extra weight is unevenly distributed among the sexes, too. In a study published in the Social Science and Medicine Journal last year, Wells and his co-authors found that, in a sample that spanned 68 nations, for every 2 obese men, there were 3 obese women. Moreover, the researchers found that higher levels of female obesity correlated with higher levels of gender inequality in each nation. Why, if body weight is a matter of individual decisions about what to eat, should it be affected by differences in wealth or by relations between the sexes? So, this is where it really becomes hard. Aside from anything else you might think about it, it really becomes hard to believe that it's just willpower. Because, again, if it was just a matter of who has more willpower, then we wouldn't see clear patterns in men and women or in wealth and poverty. And in fact, back in the day, it was the wealthier who were more overweight, because that's what proved you had wealth. You could afford to eat and have some curves and not be stick thin because you spent your entire life working yourself to the bone. That's literally what society used to do. We valued people who had a little more meat on them because it proved that they were wealthy. But now, that's not where obesity is happening. It's happening amongst poor people more than wealthy. So if it was just a matter of, I want to eat and I do or don't have access, so I will or won't eat a lot, and that makes me fat, we would still see it in the upper wealthier classes. But we don't. So again, this is where it's just thermodynamics and willpower can't be. So these distinct patterns show that there must be wildcard factors that correlate to sex, wealth, society, etc. So this leads to our first wildcard factor. All calories are not equal. The problem with diets that are heavy in meat, fat, or sugar is not solely that they pack a lot of calories into food. It is that they alter the biochemistry of fat storage and fat expenditure, tilting the body's system in favor of fat storage. If candy's chemistry tilts you towards fat, then the fact that you eat it at all may be more important as the amount of it you consume. Sorry, maybe as important as the amount of it you consume. So, since all calories are not equal, this actually makes some more sense of food deserts and swamps. If the kind of calories that are prevalent in food swamps are the kind of calories that make you gain or store weight, then people in those areas or situations are going to be affected differently. What if the biochemistry in your body that these calories are affecting is different in men and women? Could that account in part for the disparity in the sexes? This also puts a twist on the sleep and stress factors that we had talked about way back when we talked about sleep. Is it possible that stress doesn't just make you eat more or eat worse things? Is it possible that stress alters your biochemistry to change how you store or burn fat? And stress and lack of sleep aren't the only things that can affect your biochemistry. You may recall hearing something about BPA a couple years ago, or just noticed that everything suddenly had BPA-free labels on it. Well, there's a reason for that. According to Frederick von Saal, professor of biological sciences at the University of Missouri, an organic compound called bisphenol A, or BPA, that is used in many household plastics, has the property of altering fat regulation in lab animals. And a recent study by Leonardo Tresande and colleagues at the New York University School of Medicine, with a sample size of 2,838 American children and teens, found that, for the majority, those with the highest levels of BPA in their urine were 5 times more likely to be obese than were those with the lowest levels. So yes, it is possible that this chemical seeped out of plastic and into our bodies and caused some of our weight gain. This is similar to the problems arising from using Teflon or nonstick pans, as we're discovering that the chemicals that make them nonstick can actually leach into our food and then our bodies. There is a fascinating documentary about that on Netflix. And BPA and Teflon aren't alone. In any developed or developing nation, there are many compounds in the food chain that seem, at the very least, to be worth studying as possible obesogens, helping to tip the body's metabolism towards obesity. For example, a study by the Environmental Working Group of the umbilical cords of 10 babies born in U.S. hospitals in 2004 found 287 different industrial chemicals in their blood. Beatrice Gollum, professor of medicine at the University of California, San Diego, has proposed a long list of candidates, all chemicals that, she has written, disrupt the normal process of energy storage and use in cells. Her suspects include heavy metals in the food supply, chemicals in sunscreens, cleaning products, detergents, cosmetics, and the fire retardants that infuse bedclothes and pajamas. Now, that's a lot. So first of all, 10 babies isn't as impressive as almost 3,000 kids. But, from the last study about BPA, but think about this. 10 babies, 287 different industrial chemicals in their blood. Even if you said none of them overlapped, which they did, but even if you said none of them overlapped, that is still almost 30 different industrial chemicals per baby that they're being born with. Who knows what those do? Who knows what those do in combination? And the only way they can get into the baby is if they're in the mom. So that means that moms who, generally speaking, try to watch what goes into their body when they're pregnant, these moms had at least 30 different industrial chemicals in their system. That's what all of us have, at least. So, then we have to look at this list of chemicals that she has made that are shown to be potential obesogens, to disrupt how the normal process of how our cells work. I don't know about you, but I've not heard of these. I've not heard a list of, oh, watch out for these chemicals because they can cause you to be fat. No one says that. Other than BPA, which, again, I knew BPA was being taken out of stuff, but I didn't know that's because it made you fat. Or could make you fat. So, all of these chemicals we're not being told to avoid because they can make us obese? Because everyone's following the narrative of just have willpower? It's really interesting to think about. Now, one of the things she said was heavy metals in the food supply. Now, you might have become more aware of heavy metal poisoning since the Washington, D.C. or Flint, Michigan water crises in the last few decades. I had not actually heard about Washington, D.C.'s water crisis that happened a couple years before Flint, Michigan's, until I was watching a documentary about Flint, Michigan and found, oh yeah, D.C. had it too, we just never heard about it for some reason. But lead, basically, causes all of the problems. And it might also be linked to obesity. Chemicals and metals might promote obesity in the short term by altering the way that energy is made and stored within cells, or by changing the signals in the fat storage process so that the body makes more fat cells or larger fat cells. They could also affect the hormones that spur or tamp down the appetite. Now, this is not to say that all of these are definitely in your bloodstream, or that if they are actually obesogens. These kinds of things require a lot more study, with much larger sample sizes to make any definitive correlations. But as wildcard factors to keep in mind that could make us more prone to obesity, they're worth talking about and they're worth thinking about. And, the scientists note, many of these can affect babies before they're born. Going back to that group that tested umbilical cords, we already know that women exposed to lead can pass it on to their babies. But it turns out that women who are in a period of food scarcity, like during a war, pass that on to their baby too. The prenatal environment, Barker argued, tunes the child's metabolism for a life of scarcity, preparing them to store fat whenever they can to get them through periods of want. If those spells of scarcity never materialize, the child's proneness to fat storage ceases to be an advantage. The 40,000 babies gestated during Holland's hunger winter of 1944 to 1945 grew up to have more obesity, more diabetes, and more heart trouble than their compatriots who developed without the influence of war-induced starvation. Now again, these are not kids who were babies during that time. These are kids who were gestated. The moms were pregnant during this winter. And their lack of food, like their starvation mode during pregnancy, made their babies more inclined to be obese. That's not even talking about like chemicals and whatnot. That's just what the mother ate or didn't eat, or how much she ate while she was pregnant. So there are all kinds of ways scientists are discovering that what happened to our moms when they were pregnant could be affecting the development of our bodies, including making us prone to obesity now. One group found that pregnant mice exposed to organotins, tin-based chemical compounds that are used in a wide variety of industries, will have heavier offspring than mice in the same lab who were not so exposed. In other words, the chemicals might be changing the signal that the developing fetus uses to set its metabolism. So, these are wildcard factors that we might not even be aware of, and which are compounding our attempts to lose weight. And again, as we noted, it's not just what the mom does while she's pregnant, because any chemicals that she has gotten into her bloodstream beforehand, Teflon, lead, maybe these tin things, will then be passed to the baby through the umbilical cord into its bloodstream. So it's not just while she's pregnant, it's what was already in her blood before she got pregnant. So, these, believe it or not, are the more normal wildcard factors. There are wildcard factors that are a little more on the fringe than this, but they're still worth noting. The first is temperature. There is a thermoneutral zone in which a human body can maintain its normal internal temperature without expending energy. Outside that zone, when it's hot enough to make you sweat or cold enough to make you shiver, the body has to expand energy to maintain homeostasis. Temperatures above and below the neutral zone have been shown to cause both humans and animals to burn fat. And hotter conditions also have an indirect effect. They make people eat less. A restaurant on a warm day whose air conditioning breaks down will see a sharp decline in sales. Yes, someone did a study. Perhaps we're getting fatter in part because our heaters and air conditioners are keeping us in the thermoneutral zone. This would be something that affects us, our pets, and lab animals, and ties to those animals getting bigger, because we're in the same lab as the animals. We don't want to be sweating or shivering in the lab, so we put it in a thermal neutral zone. Again, something very hard to test for or definitively say, but it's possible. Another one, which is of particular interest to me, is artificial light. Now, I work nights, meaning I have the lights on all the time at night so I can see. And as we move into the summer, I'm finding it harder to sleep during the day, even with my eye mask, because it's just too bright out there while I'm trying to sleep. So, could these lights also be affecting my weight, aside from how they affect my sleep? A study by Laura Fonnekin and colleagues at The Ohio State University in Columbus, published in 2010 in the Proceedings of the National Academy of Sciences, reported that mice exposed to extra light, experiencing either no dark at all or a sort of semi-darkness instead of total night, put on nearly 50% more weight than mice fed the same diet who lived on a normal night-day cycle of alternating light and dark. This effect might be due to the constant light robbing the rodents of their natural cues about when to eat. So it's certainly possible that all of the electrical lights we have on at night, even for those who work during the day like normal, are affecting us. I already mentioned blue light from our electronics can affect our ability to sleep, and that's why companies now offer orangey filters for our phones and computers. Could they also affect our metabolism or hunger cravings or something else that affects our weight? It's certainly possible. The mice that were on a semi-darkness where it was not completely dark when they were sleeping, that's what I'm going through right now, trying to sleep during the day. So I am very much, tell me more about these rodents. So another wild card is the idea of an illness. A virus called AD36, known for causing eye and respiratory infections in people, also has the curious property of causing weight gain in chickens, rats, mice, and monkeys. Of course, it would be unethical to test for this effect on humans, but it is now known that antibodies to the virus are found in a much higher percentage of obese people than in people of normal weight. A research review by Tamahide Yamada and colleagues at the University of Tokyo in Japan, published last year in the journal PLOS1, found that people who had been infected with AD36 had significantly higher BMI than those who hadn't. So again, that is something that is hard to study in people because of ethics and all that, but the circumstantial evidence of looking at people who have already caught the bug seems to indicate that it might be a factor in human weight gain. And again, the animals it affects, chickens, rats, mice, and monkeys. Rats, mice, and monkeys are on the list of those animals that are getting fatter along with us. So something that affects them is certainly something that affects them and us, is certainly something that could be one of those wild cards that explains why it's not just humans. And it's possible, even probable, that AD36 isn't the only virus that could affect our weight or our biochemical balance. Plus, there are bacterial illnesses, not just viruses, and just gut bacteria in general. In the BBC documentary, Why Are We Getting So Fat?, Dr. Yo actually looks into gut and fecal bacteria in the latter half of the episode. There's a lot of this study going on to treat very specific illnesses that are related to gut bacteria, and doing gut bacteria transplants to help combat those illnesses. So there was a woman who was always skinny her whole life, but due to other health reasons, had to have a gut bacteria transplant from her overweight sister. And boom, she suddenly became overweight. And that goes both ways. Experiments by Lee Kaplan and colleagues at Massachusetts General Hospital in Boston earlier this year found that bacteria from mice that have lost weight will, when placed in other mice, apparently cause those mice to lose weight too. So there are other studies related to our body's bacteria ecosystem, which have, in the course of trying to treat other problems, encountered a tie to weight. So this is definitely something that bears further looking into. Part of the problem is that as a treatment, gut bacteria transplants or transfusions or anything like that, as a treatment for the things it's being developed for, is still kind of fringy science that people are still like, ugh, especially because, like, the word fecal just, ugh, people don't want to talk about that. And some people are still very, very dubious about the positive effects of this kind of treatment on the things it's being used to treat. So an off-label type treatment of, and also weight, weight gain, weight loss, that's something that's quite a ways in the future that they'll be looking into that. But it's possible, it's out there. Now, a caveat that Barabee made, and that I will make too, is that you can't just blame your overweightness or obesity on your gut bacteria, or your lights and AC, or your mom. These wildcard factors are all possible contributors, not sole causes. So, obviously, that's not the only reason. Just like willpower is not the only reason. So, why do I bring them up? In part because I find it super interesting to see how so many different things can affect us. In part because some of these studies, especially those into gut bacteria and viruses, might lead the way to helping us lose this weight in the future. And in part because this goes back to the whole willpower argument, which I feel strongly. If you had a way to look at a person and list all of the things that lead to this current weight, like let's just say magically that you could, there would be the fact that he works at a desk all day and watches the news in front of the TV at night, and the fact that he has artificial lights in his work and his house, and he lives and works in a food swamp with a fast food billboard or building right outside his work window where he sees it all day, and the fact that the current economy and whatnot has made him stressed, so he takes antidepressants, and he has to take a few other medications for other things, like high blood pressure or cholesterol. And there's the fact that he has been exposed to all kinds of chemicals and metals and stuff over his lifetime. And the fact that his mom was exposed to those things herself before she had him and while she was pregnant. And then the fact that his mom was part of a rising middle class and able to be more food comfortable than her parents. And so she was able to eat more, affecting her genetic metabolism. And then the fact that her parents, his grandparents, were from a lower class family and was food insecure. And so they went through periods of deprivation, affecting their genetic metabolism. And then there's the history of illnesses he's been exposed to, and the composition of his gut biome, and the fact that he has a sugar addiction, which is something we will talk about in the next episode. And then there's the fact that he's tried to lose weight before, and so he's yo-yoed up and down a bit. So all of these things make up the weight profile of this typical modern man. And all of these things probably have an impact on whether he is overweight or obese. And we didn't even make him a woman, which would have made him statistically more likely to be overweight. So he actually has that going for him. Now, compare all of that to the idea that, if he just had the willpower to eat less or to exercise more than he ate, he would just become thin and stay that way. That's insane, right? When you lay it out like that. So, having been told before that if I just eat less and exercise more, I would be thin and it's all my fault, this is why I found this kind of thing so interesting. There is so much more going on than what we tend to think about, and so much more complicated than just do better. That there are all these factors outside of your control. Why are you squeaking? There are so many factors outside of our control, and so many factors outside of our parents' control or our grandparents' control that can be affecting us now. And so many things, that animals are being affected, that even if we have not done as many studies about them as we have about food swamps or food deserts or sugar or whatever, that there are these things to keep in mind whenever someone tells you that you should just do better or have more willpower, or whenever you're feeling like, oh, I ate an extra serving of something, or oh, I ate a whole donut instead of a half, or oh, somebody brought cookies to work and I have one. That lapse in quote-unquote willpower does not make you fat. And a lifetime of those lapses is not why you're fat now. It's a whole host of other things. And I think that's something that roly-poly people need to keep in mind, and that scientist people do need to study more and tell us more about. And so that's something that I just had to share, even though it was not on my original list, because I discovered it while I was researching the other factors that were on the list and went, oh my gosh, people need to know this. Why are you so squeaky today? So I just really wanted to share that because I find it so important. And also something to keep in mind for morale purposes in the future. That, it's not all just your willpower or your thermodynamics or whatever. So this has been Roly Poly Weight Loss. As always, I am your host, Roly Poly. Use the hashtag Wildcard to share your thoughts about some of these factors. Any that really surprised you. I'm finding the whole branch of them fascinating, as I said. So please share that, and please join me next time.